Dear aspirants, welcome to my channel. This is a model question paper 3 applied electronics 1 for electronics and communication branch for second semester. So remaining questions, these are the 5 marks questions. With help of suitable expression, explain RD, GFS, mu measured, how determine the amplification capability in JFET. So these are the parameter. What is the parameters and role of amplification? So these are the important parameters is called drain resistance, transductance, and amplification factor. Rn or Rd you can represent GFS or GM and mu. But amplification capability of JFET should be depending upon high drain resistance, high transductance, and large amplification factor. These parameters we can determine by the voltage gain and performance of JFET amplifier. So this thing you just see the important parameter. What do you mean by dry resistance, transductance, and amplification? Here the dry resistance is resistance, the ratio of change in drain source voltage to change drain current to gate source voltage. Definition. So the definition has given change in dry source to change in dry current. GS will be a constant. There is a unit for this, that is an ohm. Coming to the transductance, it is the ratio of change in drain current to changing gate source voltage at the constant dry voltage. Here they are representing the expression I, and this is the unit for that 7 or ohm you can represent. And next will be an amplification factor mu. It is the ratio of changing dry source voltage to changing the dry source voltage at a constant dry. This is the expression for that. And relationship between the parameters mu is equal to Gm into Rd, or Gm is equal to mu into Rd, and this thing relation you should be. So this will be represent the parameters and with relations they given here. So this will be an answer for above question. Next is explain the working of transistor as a switch. In a transistor as a switch, it is in what is the use that operating electronic switches to working two regions. Okay, one is in cutoff region, switch off. One is in saturation region, switch on. In the BJT transistor, CE configuration used for switching applications. In the switch off region, okay, cutoff region is switch off region. It is based on base emitter junction. It is not a forward bias. This is transistor switch off, switch NPN. If it is switch off cutoff region, base is 0 volt. B, everything they are representing here, transistor, cutoff, and LED. Same way it is in saturation region. The base, how it will be, what is the value, how it will be react. And you just see the diagram, how it looks. This is the diagram. LED will be there. NPN transistor is there. Input, output, everything will be there. Based on no base current, no LED, no off. Finally, the summary for the what will happen in the region they are representing. Region they are representing here. If the input base 0 voltage, transistor state off, region is cut off, LED will be an off. If high voltage, it is no, close the switch, and saturation on. So it is this diagram will be representing that how it will be work. Coming to an explanation, base current is IB is equal to 0, collector current IC is equal to 0, then the transistor behave like a open switch. In the saturation region, a switch on, base emitter junction become forward bias, sufficient base current flows, collector current become maximum, the transistor behave like a close. So coming to an used for relay driving circuits, LED switchings, motor control, digital circuits, and logic gate they can use. This transistor act, it is an efficient switch, electronic switch by operating alternative cutoff and saturation region. It is widely used for electronic switchings and digital applications. The next question discuss the need of bias stabilization of CE amplifier. How do variation in the transistor parameters or temperature affect the Q point? It is need it is an bias stabilization of CE amplifier. In this bias stabilization means keeping a Q point or operating point in the transistor constant. A proper amplification operation means we have to keep this in the constant base, okay, in the transistor. The CE amplifier, the transistor should always work in an active region to get a faithful amplification. Need for bias stabilization to keep the Q point stable, to avoid deterioration in output signals, to get a proper amplification, to prevent a thermal runaway, and to improve the amplified stability and performance. It is the need of bias stabilization. If it is effect on temperature on Q point, when the temperature is increases, collector current IC will be increases, leakage current also increases, base emitter voltage also increases. As a result, Q point shift towards to saturation. The expression is equal to IC is equal to beta into IB. When increasing temperature changes, IC when changed to Q point, effect deteriorate output, improper amplification and overheat of the transistor. Next will be an effect variation in a transistor parameters. In a different transistor having a different values. So current gain is B, base emitter voltage VB, and beta is a changes when a collector current also changes. Q point shift to correct position. The final expression is IC is equal to beta into high B. The bias stabilization is necessary for a CE amplification to maintain the stable Q point and deterioration free for amplification. If the changing temperature, transist parameters also affected, and collector current and shift operating points also. The next question describes the construction and working principle of MOSFET, MOSFET. So that we call it as an enhancement type of MOSFET. This MOSFET is a voltage controlled semiconductor device which current flow only when the sufficient gate of voltage is applied. This called as enhanced MOSFET because the channel is formed by applying a gate voltage. Coming to a construction of EMOSFET, but we are using N channel EMOSFET. The main parts P-type substrate to heavily dropped N plus region called source S, drain to metal terminal placed above the substrate, thin insulating layer of a silicon dioxide between the gate and substrate. Initially, there no conducting channel exists between the source and drain. Coming to a working principle of EMSFET, there is a gate voltage is 0, positive gate voltage is applied, increasing the gate voltage. Coming to an application, we can use it for amplifiers, electronic switching circuits, digital ICs and CMOS circuits. EMS, it is used for conducting channels which will great voltage. Widely we can use it for high input impedance and low power consumption. Here below the diagram, so this is the diagram for enhancing type of N channel. So N plus is given source and drain, gate and metal gate, silicon insulator. So no channel existing, V is equal to 0. P-type subtract body it is. This is the diagram. Working principle, the condition 1 VGS becomes 0. There is no channel formed between the surface and drain. So ID becomes 0, device become off. And this has given a positive attract the electron towards NP channel induced drain ID source. When it will be Vs increases, channel become wider, ID become increases. And this will be a symbol for N channel E MSF. Okay, this is an important formula there you can use. This is the important formula. So if the content is useful, please subscribe my channel, share and support. Thank you.